All right, you are welcome to Davetuts Academy. If you're a new visitor here, wow, this is quite an interesting point in which you are joining us. And for our subscribers, you are always welcome. Now, today, what we are going to be doing is we are going to be looking at the third of a 3 series on preparation for O-level mathematics exam, whether it is WAEC, NECO, May, June, November, December, or GCSE. Now, this is the third of a 3-set video, and we are focusing on the WASSCE 2018 mathematics. Now, if you are here to subscribe, quickly click on the subscribe icon, click on the notification icon, so that you can get instant notification of our videos once we upload them for you to prepare for your academic excellence. And here we're having our first question, question number 10. Here we are given a triangle PQS. PQ is 12 centimeters, PS is 5 centimeters, and SPQ and PRQ is 90. We are asked to find Y, the line PR denoted as Y. Now, what we need to notice here in this diagram is that we are having two right angle triangles, and the right angles are being shown in yellow, and we are asked to find this line PR, which is being denoted as Y. So how do we go about this? First, if we are to use Pythagoras Theorem, we can get the value of the line SQ. So from the triangle PQS, we can use Pythagoras Theorem, and Pythagoras Theorem tells us that the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. Now, our hypotenuse in this case is SQ, which we are looking for. We know PS and we know PQ. So you can say SQ square is equal to 5 square plus 12 squared. And that is 25 plus 144. That will give us 169, such that SQ will be the square root of 169. And that is 13 centimeters. So SQ is 13 centimeters. Then we can go ahead to see how we can find this PR, since we now know all the 3 sides of the bigger triangle. Now, there are quite a number of ways that we can use to get this value. If we are to draw out the triangle again, I will show 2 methods that we can use. We have a right angle here, we have 5, 12, and now we have 13. If we label our triangle, and then if we are to complete the triangle as given in the diagram, this is what we are looking for. Now, looking at this, one of the methods that we can use to solve this is to divide this base, the line SQ, we can divide it into 2. Call one on the side X, and then the other side will be 13 minus X. And then, using this, we can employ Pythagoras Theorem and say, okay, now we have 2 triangles. If you are to look at the smaller triangle, the triangle to the left hand side, you can find that 5 square is Y square plus S square, and to the right hand side, we can see that 12 square is Y square plus 13 minus S square. Now, from both, we can say Y square on both equation that we just wrote will be 5 square minus S square, which is 12 square minus 13 minus S square. So, using this, we can solve for X, and after we solve for X, we'll use the value in Y. This is one way to go about it, but I'm not going to use that way. I want to use another method to try and find the value of Y. Now, if I'm to take this angle at point S and call it theta, now from the triangle PSQ, we can evaluate that the trig ratio sine theta is equals to opposite over hypotenuse. So that opposite is 12, the hypotenuse is 13. Now, also from the triangle PSR, we can also define the same theta, sine theta is equal to opposite, which we are looking for, and the hypotenuse, which is 5. So that will be Y over 5. Now, since is the same value of sine theta, we can equate these two, 12 over 13 and y over 5, and we can easily get the value of y. And now, I took my time to break this down. Instead of just saying, let's use similar triangles. This is actually similar triangles. And when we cross multiply, y will be 12 times 5 divided by 13, which is 60 over 13. And if we bring in our calculator, let's bring in our calculator, 60 divided by 13, that will be 4.6154 centimeters. 4.6154. And if you are to find that correct to three significant figures, PR will be 4.62 centimeters. Alright. Now here, question number 10b, we are given the length of two ladders L and M to be 10 meters and 12 meters, and they are placed against a wall such that each ladder makes the same angle with the horizontal ground. Now the foot of L is 8 meters from the foot of the wall. We are to draw this and then we are to calculate the height at which M touches the wall. Now for this type of question, a good understanding of all we are saying, what the question is asking, will help us to solve it. So if you are to draw the ground and the wall, and then we have two ladders. Let's say the first ladder here, 10 meters. Now, for them to make the same angle with the horizontal, that means inherently they are going to be parallel to one another. Because the angle here, theta, will also be the same angle here, theta. If you look at them, they look like corresponding angles that are facing the same sides. So that makes the 12 meters and the 10 meters, the ladders, that makes them parallel to one another. So now if you have to label our diagram, okay, now that's the first question we're asked to do. We've drawn the diagram, we've illustrated the diagram. So now we need to calculate the height at which M touches the wall. Okay, maybe we can relabel our diagram. Instead of E and D, maybe we can use L and M as given to us. Okay, let's use L and M. So we have L and M. Okay, so the height we are asked to find is from M down to point C. That's the height at which ladder M touches the wall. Now, if you are to look at this, how can we go about this? How do we go about this? Okay, we need to notice that we are having two triangles here, and for one of the triangles we know two sides. We don't know the third side. On the other triangle, we only know one side. We don't know the other two sides. But again, we have said that the ladders are parallel to each other, and this is a right angle triangle. And they're also having the same base angles as noted in the diagram. So, interestingly, we can use the principle of similar triangles to solve this, such that from the smaller triangle, let's say line LC is X, and then on the other triangle, let's say MC is Y. We can relate the length of the hypotenuse and the length of the opposite. Now from triangle BCL, the smaller triangle, if we are to use Pythagoras Theorem, we can find the value of X. So we know that BL square, which is the hypotenuse, is BC square, that's the adjacent, plus LC square, that is the opposite. So we know BL to be 10, then we know BC to be 8, and we are looking for LC, which is X. So S square will be 100 minus 64, and that is 36. such that our x will be square root of 36, and that is 6 meters. Now, we've gotten x to be 6 meters, and then we can go ahead to use the principle of similar triangles relating the ratio of the sides to one another to get the value of y. Okay, I need to create some space on my workboard so that I can put the solution to y right beside what we just worked out. So let me try and move this. Let me try and move this calculation that we have done. Okay, so I can erase the theorem so that I have my space. Okay, good. And now, since we want to use the principle of similar triangles, now we know the hypotenuse for the two, and then we are looking for the opposite for one. The ratio of the opposites will also be equal to the ratio of the hypotenuse. So x over y will be 10 over 12. And we have found our x to be 6. And this is directly coming from the opposite. X and y are the opposites. 10 and 12 are the hypotenuse. So now if we cross multiply this, we are going to have 10y is equal to 6 times 12. So y is 6 times 12, which is 72 divided by 10, and that is 7.2 meters. That is the solution to question number 10b of WAEC 2018. Wow. Here we have come to graph, and I know for a lot of students, this is a thorn in their flesh. But believe you me, it doesn't have to be. This is one of the cheapest questions you can attempt, and let's solve this together. So we are given y is equal to 2x squared plus x minus 10, and we are to complete this table for the values of x between minus 5 and 4 inclusive. And now that table is given to us. Now what I will advocate for is that you need to work smartly. You don't need to stress yourself just giving yourself a all of headache, like saying you want to be substituting each value of x, like when x is minus 5, then y will be 2 into minus 5 square plus minus 5 minus 10, and then you want to expand that bracket, and after expanding the bracket, you also go on to the next value, then take s6. Now you have gotten this is, now y will be 35, then you also want to go to when x is minus 4, you also want to say y will be 2 into minus 4 square plus. Now the tendency for this is that you get bored easily and you lose concentration and you miss it. I'm going to provide a smart way to work around this with your calculator. For those of you using the functional scientific calculator, you can always input your equation, which is one of the methods I'm going to show. So first method is that now define your equation. When you press alpha and the second bracket, you get x. So we want to put in this equation 2x squared plus alpha x minus 10. This is the equation we are given. And now what you want to do is you want to solve. You want to solve by this. You want to calculate. And now when you said calculate, it's asking for the value of y. And we put in minus 5. And when you press equal to, the value is out 35, just as we got the other time. Now, as simple as this is, you can also use it for each of the values of x. Now, when x is minus 4, your value is 18, and you do it continuously down to when you get 4. So, you can just input your value and say, okay, now, this is 2 into 16, and then you have 18. But I will advise personally that you just solve out your equation in the smart way using your calculator, and then at worst just write out the first line of an equation, and the next line you input your value. Now when x is minus 3 equal to your y is 5, as seen in the figure that was given to us before. When x is minus 2, the value is minus 4. So yes, minus 4, and you are good to go. As simple as that. And then you can do that for the whole of the other values. But now, I want to use another method. There is a table in your calculator. When you press the mode, now here in my calculator, 7 is for table. So when I press 7, it's asking me for the function of x. My function of x is y, because y is what I'm trying to solve for. It's a function of x, which is 2x squared plus x minus 10. Interestingly, I can also put in another function. So the calculator is also asking me, do I want another function, g of x? Now, if you look at this question, in our question C number 2, we are given that 2x squared plus x minus 10 equals to 2x. The left hand side, you will see, is equal to y. So here is as if we are saying y is equal to 2x. So the second function is actually 2x. And knowing this, so right from the time I'm starting my calculation on the graph, I can input the two functions. So gx I will call 2x, and then I will go ahead to generate my table. I want to start from minus 5, so I press minus 5. I want to end at 4, so 4. And the step, the increment is 1, because minus 5 to minus 4 is 1, and on like that. And now, voila, once I press my equal to, my table is out for me. Now, x is showing the values that I'm inputting. Function of x is 2x squared plus x minus 10, and g of x is 2x. And easily with this, I've generated a table. I can confirm with the values that already have been given to me in the table from the question. But I will just input my values once I see that they tally, and I'm good to go. So I have 35, 18, 5, which is correct as given. And when x is minus 2, my y is minus 4. Minus 2, minus 4. So now you can see when it's minus 1, it is minus 9. When x is 0, it is minus 10. When x is 2, when x is 1, y is minus 7. And all my values are already gotten for me. So using your calculator can really help you to work smart, so that you don't even miss any value. You get all your values and you are good to go. So now the first question on the graph is done and dusted. Then we want to go to our graph paper, and now we've been told the scale to use. We have to use scales of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on the y-axis. And we have to draw the graph of y for the range of values minus 5 to 4. Now, on the graph paper is divided into squares, and now each of the squares is going to take some unit. I've looked at the graph and cited where my center line should be, so that it will be quite valuable to see on the graph. So now I've noticed that my center coordinate should be towards the base of the graph, such that I will have space up, and then I can label 2 cm to 1 unit on the x-axis. That's why I have a gradation of 1. But on the y-axis, 5 cm to 2 cm to 5 units. So I have gradations of 5 on the y-axis. Now, having done that, I want to look at each corresponding values of x and y. When x is minus 5, y is 35. So at that point, I want to use the cross, yes. So x is minus 5, y is 35. When x is minus 4, y is 18. I have 15, 16, 17, 18. 15, 16, 17, 18. Okay. And then when x is minus 3, y is 5. When x is minus 2, y is minus 4. Minus 4 just before minus 5. When x is minus 1, y is minus 9. 0 and minus 10. 1 and 7. 1 and minus 7. 2 and 0. 3 and 11. 4 and 26. Alright. Now, having done this, I need to join all my lines together. Now, if I'm doing this in the real life, I will use a French curve, or sometimes I use a broomstick. Yes, I remember those days. We used to use broomstick and you get your perfect curve. But now, I'm limited by my digital board. I will do my best to make sure I get a line of best fit. That is not it. I'm speeding up the video to show. Wow. No. No, that's worse. Okay, that's fair. Alright. This is not easy actually. Using your free hand. No. Alright. This is better. So yeah, joining the points, I've gotten the graph of y equals to 2x squared plus x minus 10. That is the graph as requested for me to draw. And now, once I've gotten this, that question number B is also solved. But now we have to use the graph to find the solution of 2x squared plus x equals to 10. If we take 10 to the left hand side, it becomes minus 10 equals to 0. That means the point at which the graph is equal to 0, meaning that y is equal to 0. That's the point at which you solve for this. And normally the language is that where the graph cuts the x-axis, where it cuts the x-axis, y is actually 0. So if you are to trace that here, let me use another ink. This is the first point and this is the second point. On these 2 points, these 2 points are the solution to the equation 2x squared plus x minus 10. And from the graph, if you are very observant, this solution amounts to x equals to, this will be minus 2.5, and then on the right hand side it is 2. So that is the solution to the graph 2x squared plus x equal to 10. And now for the last question, question number C2. Question number C2, as I was noting initially, 2x squared plus x minus 10 equals to 2x is amounting that y is equals to 2x. And then, okay, maybe we can draw our table to show the values of y for each value of x. Since we have another function here, we can draw our table. So now let me bring in the table for y equals to 2x. Y equals to 2x. I want to evaluate the values of y is 2x. Now, you remember when I was inputting my data into the calculator, I used g of x to be y. So you can as well just use your eyes to multiply 2x. That's quite easy. But sometimes the function may be quite a bit bogus, but then my calculator would have solved it out. So I will input all those values: minus 10, minus 8, minus 6, minus 4, minus 2, 0, 2, 4, 6, and 8, because it's just multiplied by 2. So now, if I were to plot this graph also, y equals to 2x is actually a straight line graph with, here, they are saying that there is no intercept, it's just y equals to 2x. But we are going to use that. When x is minus 5, y is minus 10. Now I'm using black ink. When x is minus 4, y is minus 8. Okay. When x is minus 3, y is minus 6. When is minus 2, minus 4. Okay. Minus 1, minus 2. And correctly, no intercept, 0 and 0. And then 1 and 2. 1 and 2. 2 and 4. 3 and 6. And 4 and 8. 7, 8. Okay. Now, this is actually a straight line, so we can use a straight line. A ruler will be appropriate for this to join all the points together, and we can define that as y equals to 2x. Now we've gotten our y equals to 2x, and then the solution that we're asked to find will be the point at which the line y equals to 2x cuts y equals to 2x squared plus x minus 10. And that is being noted in our colored ink again. So from the graph, the point which is the solution to the equation 2x squared plus x minus 10 equals to 2x will be x equals to minus 2, or x is equal to 2.5. And that is as simple as it can be. You don't need to be intimidated with the graph questions. If you know what you're doing and you work smart, use your calculator as a tool to enhance your work, you can easily get your question without any hassle. Now, some people make it a point of duty to write the scale at the right hand side of the upper of the graph, the scale for the x-axis, the scale for the y-axis. It's a good thing to do, and it will earn you your full mark. So now our question number 12a, we are given that x is this matrix 2 and 3, y is matrix 5 and minus 2, z is matrix minus 4 and 13. Now we are asked to find the scalars p and q so that px plus qy is equal to z. All you need to do is just to bring in p and q into these matrices. So I will bring in p and q into the matrix. We are going to have this, and then what this will form is a set of simultaneous equations, which we have 2p plus 5q is equal to minus 4. Then 3p, now we have minus 2q, because minus 2 is there at the base, equal to 13. Now these are two equations that we can choose to solve, equation 1 and equation 2. We can solve them simultaneously, and we can find the value of p and q. Now if you want to solve this simultaneously, let's say we want to use the elimination method. We multiply equation 1 by the coefficient of p in equation 2. That coefficient is 3. So we have 3 into 2p plus 5q equals to minus 4. And if we expand the bracket, that will be 6p plus 15q is equal to minus 12. 3 was used to multiply everything. Then equation 2 multiplied by the coefficient of p in equation 1. That coefficient is 2. So we have 2 into 3p minus 2q is equal to 13. So we have 6p now minus 4q is equal to 26. Now looking at these two new equations, 6p is common to both. So if you are to subtract the 6p's, we subtract themselves out, and it's as if we are putting the negative number into each value of this equation. So 6p minus 6p will be 0. 15q minus 4q will give us 19q, and we also have the other. So we have 0 plus 15q minus 4q is equal to minus 12 minus 26. So the two negative sign will turn to plus. So we have 19q is equal to minus 38. So that q is minus 38 over 19, which is minus 2. This value of q we can reuse in any of the previous equation we have found out. Let's say we want to pick equation 2. From equation 2, we want to use q equals to minus 2 in equation 2. So we are going to have 3p minus 2 into minus 2 is equal to 13. So 3p plus 4 is 13. So that 3p is 13 minus 4, which is 9, and p will be 9 divided by 3, and that is equal to 3. That is the value of P and Q that we are asked to find. Now, question number 12b, another graph for us. So students, as much as possible, please prepare to lay your hands on the graph. It's not as difficult as you think. Looking at this question now, we're asked to indicate on the graph the vertices and the coordinates of a quadrilateral WXYZ, and the values of the coordinates are given, and then we have to find the image rotated in an anticlockwise rotation of 90 degrees. This is where we want to have problem, but now the anticlockwise direction is opposite the clockwise direction as shown on the board. So now, if we are to consider our Cartesian coordinates, I just want to use this to explain. If you are to turn this by angle 90, now, if you label it as this is y and negative value of y, x and negative value of x, by the time we rotate that by 90, this is what is going to happen. This x will move up, then the y will move to the left hand side, so it will become minus y. Then the minus x will move down, it will become still minus x. Then the minus y will move to the right, and that will be y. Now, looking at this, you can notice that it's just as if we are rotating the value of each of the coordinates, and this actually can be noted like this. Now, when you want to rotate in an anticlockwise rotation of 90 degrees, this is what is going to happen. X will become y, and then y will become minus x. Now, let me just cite two examples that will clarify this. Just two examples that will make this very meaningful to us. If you have a point A that is defined as 1, 2, if you rotate it, anticlockwise rotation, 90 degrees, x becomes y. So 1 becomes y, and then 2 becomes minus 2. Or we have B minus 3 and 4. So the new position will be x becomes y, it is minus 3, y becomes minus x, that will be minus 4. So with this rule of thumb, all we need to do is to apply this in the question that we're asked, and our solution will easily come out. So let's bring in our graph paper again. Let's find a way to bring our graph paper. Okay, before we do that, now let's say for these values that we are given, w, x, y, and z. So now the y1 that had been rotated, the w1 that had been rotated, I mean, now x will become y, x is now 2, y will become minus x, that is minus 3. The x1 that is rotated, now x becomes y, so y will be, then y becomes minus x, that will be minus 1, which is 1. The y1 will be x becomes y, so minus 4 is still, minus 3 is still there, then y will become minus x, which is minus 4, and that is 4. And then for the third one, x becomes y is minus 3, y becomes minus x, so that will be minus 2. So these are the values that we need to note on our diagram and we need to show on the graph paper. So if we bring in our graph paper now, and now this we can actually centralize. You can centralize on both the horizontal and the vertical axis. And yeah, I'm not going to note it, but I'm using a scale of 1 centimeter to represent 2 centimeters to represent 1 unit. 2 centimeters to represent 1 unit. So you have to put that 2 centimeters to represent 1 unit on both the x and the y axis. What I'm going to be having will be, let's say this is y and this is x. Then on 0, what we are going to be having will be 1, 2, 3, 4. 1, 2, 3, 4. Then negative minus 1, minus 2, minus 3, minus 4. Then minus 1, minus 2, minus 3, minus 4. Let's start with each of these points. Now, we are told that W is 2 and 3. X is 2, Y is 3. So that is W. This is 2, 3. Then X is 4. X is 4, Y is minus 1. 4 minus 1. So we have 3x 4, minus 1. Y is minus 3, minus 4. Minus 3 and minus 4. So this is Y minus 3 minus 4. And then Z is minus 3 and 2. Minus 3 and 2. Z minus 3, 2. So now to complete our quadrilateral, we need to join all these points. Let's do that. Let's do that, and our quadrilateral will come up quite easily. And just like that, we have completed question number 12B, Roman numeral 1. So now we can move on to the image under an anticlockwise rotation of 90 degrees. Now, W will be minus 3, 2. And if you're observant, that is exactly the same position as Z. So here we have W1 minus 3, 2. Then X1 is 1, 4. X is 1, Y is 4. 1, 4. So this is x1, 1, 4. Then y1 is 4, minus 3. X is 4, y is minus 3. So this is y1, 4, minus 3. And then z1 is minus 2, minus 3. So x is minus 2, y is minus 3. Z1 minus 2, minus 3. We can also join all these points together to show the image of the quadrilateral under the anticlockwise rotation of 90 degrees. And this is what we are going to get. Now, if you are quite artistic and you are quite observant, you will notice that this line and this line are equal. This line is the same as this line. Then you will just notice the symmetry about the rotation as requested for in the diagram, and it's just as simple as this. Finally, our last question on WAEC 2018 mathematics. We are given a frequency table that is showing the mark distribution of a class of 30 students in an exam. The mean mark is 52, and from this we also find the value of x and y, construct a group frequency table starting with a lower class limit of 1, class interval of 10, draw histogram, and use it to estimate the mode. Now we have to come out with our table for these values because we want to sum everything. Now x will be our mark, f is our frequency, fx is the product of the two, and then we want to replicate this information in our own table. Frequency is 1, 1, x, 5, y, 1, 4, 3, and 1. Now the product of the two, of the mark and the frequency, is here. This will be 30x, this will be 200. Now 50y, 60 times 1, 60, 70 times 4, 280, 80 times 3, 240, 90 times 1, 90. Now the sum of these, you can find this sigma f. You can find sigma fx. Now, sigma f, if you sum all this, will be 16 plus x plus y. And then sigma fx will be, I think we need to bring in our calculator, 30x, 50y, and then all these other values. Let's input them. No, not f of x. We need to return to our normal mode. Okay, so 10 plus 20 plus 200 plus 60 plus 280 plus 240 plus 90. That's 900. Okay. So sigma fx is 30x plus 50y plus 900. But now, in the question we have been told that the total number of students is 30. So the sigma f, the total frequency, which we got to be 16 plus x plus y, is actually equal to 30. We can note that because we are going to make use of it in finding the values of x and y. Now, I've cleared my table and I want to do the working now. For this group data, the mean is sigma fx divided by sigma f. And now, sigma fx we have found to be 30x plus 50y plus 900. Sigma f we have found to be 16 plus x plus y. Now, this mean had been given in the question to be 52. It had been given originally to be 52. So now, with this new expression, if you cross multiply with this new expression, (3x plus 50y plus 900) equals to 52 into 16 plus x plus y. But alternatively, we could have said that 52 multiplied by 30. But let's go ahead. 52 multiplied by 16 is 832. 832 52x plus 52y. So yeah, if we collect like terms, 30x minus 52x plus 50y minus 52y equal to 832 minus 900. So yeah, minus 22x minus 2y will be equal to minus 68. Now, all are divisible by 2. So if you are to divide all through by 2, we can have, let's divide all through by minus 2. So that the negative will even cancel out. We have 11x plus y is equal to 34. So now, if you are to look at sigma f, that can also constitute another equation for us, because we will see that x plus y will now be 30 minus 16. 30 minus 16. 30 minus 16 is 14. So if you are to write that, x plus y is 14. Now, we have two equations. We can solve them by whatever method we want. Now, I can see that y can easily be eliminated if I subtract equation 1 from 2. Note I reversed my order. So I say equation 2 minus equation 1. 11x minus x will give me, 11x minus x will give me 10x. Y minus y will be 0. 34 minus 14 will be 20. So x will be 2. Now, since I've known the value of x, I can substitute in any of these equations to get the value of y. Now, I want to use equation 1 now. So y will be 14 minus x, which is 2, meaning that y will be 14 minus 2, and that is 12. So what we are first asked to find is the value of x and y, and we have noted them to be 2 and 12. Now we have to draw our group frequency table. We want to get our class interval. It had been given to us initially using a class interval of 1 to 10. We can fill up all the table, fill up the table for each class interval. Now, after filling this table, now we can get the upper class boundary. Now, the upper class boundary will be the first entry in the class interval minus 0.5, and that will be 1 minus 0.5, which is 0.5. The next one will be 11 minus 0.5, which is 10.5. The next one, 21 minus 0.5, 20.5, and on like that. Now we could also have we could have found the extent of the class boundaries 0.5 to 10.5, but it's alright. This is sufficient for us to use in our histogram diagram. So after finding all this, if you notice in my table, instead of x and y, I put in the value of 2 and 12 for the frequency. So now we can construct our histogram by looking at the x and the y axis. Now I've scaled with my eyes to know that this is the best fit for my graph. So I have my frequency, I have my upper class boundary. So now on the frequency scale, I'll be using a linear scale of 2 centimeters to represent 2 units. So my gradation will be 2, 4, 6, 8, 10, 12, 14. I'm having 12 as the highest number. But now on the upper class boundary, it's not going to be linear. I'm going to start with 0.5, then put in an increment of 10 as shown in the diagram. 0.5, 10.5, 20.5, and on like that. Now, if you want to draw this as an histogram, when the frequency is 1, my upper class boundary is 0.5, and then when it's also 10.5, it's still the same one. It is 2 when I'm going to 20.5. It is 5 when I'm going to 30.5. It is 12 when I'm going to 50.5. So we'll go to 12 on the scale. Yes. Then it is 1 when I'm going to 50.5. It is 4 between 60.5 and 70.5. It is 3 between 70.5 and 80.5. So now I'm going to draw the whole of this and join them appropriately. The last value is 90.5. So now with this, I've constructed my histogram with no space in between, which is the characteristics of the histogram, and then plotting the upper class boundary with the frequency. To find the mode, I'm going to look at the highest entry, which is 12, and then cross from the 2 side entries such that the point of intersection I can trace on the class boundary to note the value. And now for this is like this value now will be around 44.5. Yes, that will be around 40, 42, 44, 46, 48, 50. Yes. So from the graph, the estimated mode now is an estimate. So there's margin for some allowances. From the graph, it is 44.5. You can say for the allowances plus or minus 1. And now that has brought us to the end of all the theory questions from WAEC 2018 mathematics. The journey has been quite long, but we have reached the end. This is an exam prep, and sincerely speaking from the bottom of our hearts, we desire that you go out there and be the best in academics. Just don't forget to like the video, share it, subscribe to the channel, and until next time, God bless you.